Assalamu alaikum everyone. This is a project implementation demonstration video for the course EEE 202 hardware titled Diode based voltage, doubler, tripler and quadrupler. This project was completed by the students of Group 3, Section B1 of Level 2 Term 1 of the Department of Electrical and Electronic Engineering. The primary objective of this circuit implementation is to observe the different levels of output voltage multiplication. We will also verify that the output is DC and properly rectified along with the observation of ripple voltages under loaded condition. For the input of the circuit, to facilitate easier charging and discharging of the capacitors, we chose a square waveform having 5 volts peak with 1 kHz of frequency. Here is the schematic circuit diagram of the project according to which the actual circuit was built. For the actual circuit, we used capacitor values of 10 microfarad and the diode model that was selected was 1N5408. The circuit was constructed taking into consideration the node notation that was used in the schematic diagram. Now we jump straight into the action by firstly connecting the function generator across node 1 and 0 of the constructed circuit. Then the oscilloscope channel 1 was connected across the second capacitor from the input side or across the node 0 and 4. Observing the output waveform shape, we can say that the input voltage was almost doubled and rectified. Then to demonstrate the voltage tripler in effect, the oscilloscope channel 1 was connected across the first and third capacitor from the input side or across the node 1 and 3. The oscilloscope output shows that the input voltage has tripled along with being rectified. Lastly, for the quadrupler circuit, the oscilloscope channel 1 was disconnected from the previous position and the channel 1 was now connected across the second and fourth capacitor from the input side. Again, the oscilloscope output window matches our expectations. The voltage is almost quadrupled and the output is also rectified. Moving on to the voltage ripple observation segment, here a resistor was connected across doubled voltage nodes to simulate a loaded condition for the voltage doubler. For 10 kΩ resistance as a load, a sinusoidal input shows significant amount of ripple voltage in the output. In the same particular scenario, increasing the resistance to 50 kΩ reduces the ripples noticeably. Again, making the resistance 100 kΩ makes the ripple negligible, which is evident through oscilloscope output. In case of tripler circuit's loaded condition, the resistance was added taking into account the proper nodes that gives tripled input voltage as output. Again, in this case, a high resistance value, for instance here 100 kΩ, produces almost unnoticeable amount of ripple. Finally, the quadrupler circuit's loaded condition was constructed ensuring the load was connected parallel across the second and fourth capacitor from the input end. The output is as expected and ripple is again low to none due to high value of resistance. While reviewing the output of the loaded conditions, voltage drop across diodes were also measured to check if the voltage drop is within the rated range and also so that the voltage multiplication deviations or inaccuracy could be explained. All the diode voltage drops were within the rated range of the model and the experiment was completed without any equipment failures. In conclusion, the experiment was wrapped up with some key observations. These included the reasons behind the deviation from the ideal multiplication voltage, the dependence of ripple voltages on the resistance values, and the observed behavior of the ripple properties.